Dear students, this is the continuation of the previous video. Okay. Now, we are going to see linear non-homogeneous recurrence relations. Okay. Now you see here, what is the general form of that non-homogeneous recurrence relations? You see, an is equal to c1 an minus 1 plus c2 an minus 2 plus etc. plus ck an minus k plus here fn, some function. What is that? See the examples here. That function may be n, maybe some linear, or maybe quadratic, or maybe 2 to the power n, or minus 5 to the power n, like that. Okay. So now this is called linear non-homogeneous recurrence relation. Okay. But all the coefficients are constant. That is same what we have seen in the linear homogeneous equation. That C1, C2, etc. Ck all are real constants. Okay. Now, how to solve this? Say solution of non-homogeneous equation. How to solve this? Suppose second order non-homogeneous equation is given. That is here. Okay. Okay. Now, here what we have to find? We have to find the complete solution. For that, here what we are doing, we will find the general solution for the homogeneous part and the particular solution. Then we will add both. See, homogeneous solution and particular solution we will add. Then we will write the general complete solution. Okay. How to do? We will see this through one example. Okay. Now, before that, here few multiple choice questions are there. Okay. How to identify the homogeneous? How to identify non-homogeneous? How to find the degree? Okay. Now you see here. Determine which of these are linear homogeneous recurrence relations with constant coefficients. Also find the degree of those that are. Okay. Now you see here. This is the given recurrence relation. Okay. Now here two questions are there. Okay. Determine which of these are linear homogeneous. First we have to confirm whether it is linear or non-linear. Means linear, homogeneous or not homogeneous. Okay. And then we have to find the degree. Okay. Now here, that's why here they given the answer. Yes, this is linear homogeneous recurrence. Yes. Degree is 3. Yes. Here you see. Okay. Degree is 3. Now this is not linear homogeneous. Why it is not linear homogeneous? You see here, linear and in non-linear, in both the cases, now here the coefficients are constant. Now you see here 2n, 2 is constant, okay, but the n is not constant. Okay, see, that is the reason 2n is not a constant coefficient, so that it is not linear homogeneous recurrence relation. Okay, because here what is asked? Constant coefficients with constant. No, it is not constant coefficient. Okay. Now this equation means C. Yes. See here. Constant, constant, constant. No n. Okay. And it is linear. Okay. It is homogeneous. Yes. So linear homogeneous reconciliation with constant coefficient. Yes. What is the degree? You see here. Degree is 4. Okay. Similarly, you can see the remaining questions also. Now you see here. In the non-homogeneous general form, here we have Fn. Okay. For Fn, we have to find the particular solution. We have to find the particular solution. We have to find the particular solution. Okay. How to find the particular solution? For the particular solution, how to write the form of the particular solution? Then we have to find the particular solution also. How? You see here. What is the general form of that Fn? Means Fn is given any one of this in the equation, in the question. But how to write the particular solution form from Fn? Okay. Now, suppose Fn is, you see here, suppose Fn is any constant. Okay. Any constant. Maybe 5, maybe 3, maybe 2, maybe 7. Any number is given here. Any number is given in the equation. Any number given in the equation. Then how to write the particular solution form? If any number is given for Fn, only number is given for Fn, then you write A. Suppose for Fn, they given n, which means linear, okay, or C multiply n. This is also linear. Then you would write the general form of the ANP, means particular solution form is ANP. Okay. Suppose for Fn, they given Cn square, means quadratic. Okay. Then you would write AN square plus BN plus C. Okay. Now suppose they given CR to the power n, which means R is any number to the power n. Suppose here this number is coinciding with your characteristic roots. According to that, you would write this value. Okay. When we discuss the question, I will tell you. This is the general formation. Okay. See here, only constant before this R to the power n. But here before R to the power n, we have n squared. Okay. What we are doing for n squared? For polynomial, we are doing an squared plus bn plus c in the particular solution form. Now that's why for n squared you write an squared plus bn plus c. But for r to the power n, here occurring in f of n, so that you multiply r to the power n with this. Okay, this is the form of an p, which means the trial function. We can say trial function of the particular solution. Okay. Okay. Now these are few more examples. Okay, this is the general case we are discussing here. Here you see here. Consider the, you see in this example, consider the reconciliation. An is equal to 5an minus 1 minus 6an minus 2 plus fn. Okay. Now, see, for this, we are finding the characteristic equation for the homogeneous part. For the homogeneous part means you consider only this, find the characteristic equation. From that, you find the characteristic roots that are 2 and 3. Okay. 2 and 3 are roots, characteristic roots. Okay. Now, what is the question here? Actually, they're not asked to find the complete solution. No, because here Fn is not given. But for Fn, for these different cases, how to write the particular solution form A and P, how to write the trial function of the particular solution. Okay. Now, you see Fn. Okay. Here, first case. What is Fn? Fn is 2n squared. Suppose Fn is 2n squared, how to write the trial function of the particular solution? Okay. How to write? You see here, you see this is n squared. Okay, this is quadratic. So what do you do for quadratic? What do you write? For quadratic, what do you write? A n square plus b n plus c. Okay. Write a n square plus b n plus c. Finish. Okay. Whatever number is given, no issue. Here you see the term n squared. So this is the polynomial with the degree 2, so that you write the same second degree polynomial, means general form. Okay. So what is the general form of the second degree polynomial? This is the form a n squared plus b n plus c. So that this is the trial function of the particular solution. Okay. Suppose your Fn is 5 to the power n 3n squared plus 2n plus 1. Okay. Now you see here, for this, see what is this? This is the again second degree polynomial. This simply, if n squared is given, this is also a second degree polynomial. If this is given, yes, this is also second degree polynomial. So how to write the trial function? Yes, a n squared plus b n plus c. Okay. Now you see r to the power n. Okay, you see here r to the power n, any number power n. Okay, now whenever you get 5 power n, 3 power n, 2 power n, minus 7 power n, any number to the power n, immediately you have to check this number, this 5. See, this 5 is matching with your characteristic roots or not, equal to roots or not. Now, see, this is 5 to the power n. So this 5, no, not matching with the characteristic root. So simply you write 5 to the power n, multiply this, finish. Suppose it is matching, what to do? We will see next. Okay. Now you see f of n equal to only 5 to the power n. Only 5 to the power n. What to write? You see here only r to the power n with some number r to the power n. Just write this. See now 5 to the power, again 5 is not matching with the characteristic roots. So I can write a n power p is equal to 5 to the power n multiply some constant only. Okay, see here some constant. This is the form. Okay. Now Fn is equal to 3 to the power n. Now you see, you have to be very, very careful. Now you see this number 3 is matching with, yes, one of the root. Yes, matching with one of the root. So what you do, if this number is matching with one root, then you multiply by n on time. Okay, multiply by n. Then remaining means rest is same. See, 3 to the power n you write, then multiply one constant, but extra is one n. Okay, because this number is matching with one root. Okay, matching with one root. Okay. Now what is the last case? F of n is equal to 2 to the power n multiply 3n plus 1. Okay, then how to write? Now see, first for this polynomial, this is polynomial linear, degree is 1 here. The degree of n is 1 here. So you write an plus b. Okay, okay, this is finished. Okay. Now see, this 2 is matching with one root, matching with another root. Okay, see here 2 is matching with one root. Okay, okay. So now if this number is matching with one root one time, okay, so you write means multiply n for this 2 to the power n means 2 is matching with one root, so you multiply n, then rest is okay, 2 power n you write. Now you can ask me why we don't write some constant here. You see here some constant we have written a, but here we don't write. Why? Because already we have constant here in the linear form. Already we have constant a and b, because this is the product 2 power n multiply n, you have to multiply inside. Okay, already you have constant, so no need to multiply another constant here. Okay, that's it. Now we will see another example also. What form does a particular solution of the linear non-homogeneous recurrence relation? Okay, see, I have this equation. Okay, then I have different functions. We have to tell which trial function for the particular solution is suitable. How to write? Okay, now you see here. You see here, two roots are different here, 2 and 3. But you see here, first write the characteristic equation. This is the characteristic equation. Then find the roots. R equal to 3. Yes, here degree is 2, R is equal to 3, multiple root they are writing, which means R equal to 3, 3 and 3. R is equal to 3 and 3. Okay, 2 times. Okay, R is equal to 3 and 3. Okay, now you see here, what is the first option? F of n is equal to 3 power n. Okay, now you see this number is 3 matching with the root 2 times, so that you have to multiply here n squared simply. You see n squared. What is p naught? Any constant. This is up to you. You can write a or b or c1 or alpha 1 or p naught, any constant. Okay, but important thing, why we multiply here by n squared? Because this number 3 is equal to the root, but that root is 2 times, so that you multiply here n squared. You see here 3 to the power n, but this number 3 is equal, means same as with one root, so that I multiply only n here. Okay, okay, so that now here p naught n power 2 3 power n. Okay, now n multiply 3 power n. It's interesting. Now you see here, for n what you write? One polynomial. Okay, already told you p1 p naught are constant. You can write any number, means any constant, a b c d c1 c2 anything. So here p1 p naught, so this is the linear equation because here n. Okay, next 3 to the power n, this number, this 3 is matching with the two roots, matching with two roots. Okay, so what you do, again for that you multiply n square, then outside you put 3 power n, this same. Okay, again here outside don't put any constant because already you have constant in the linear form. Okay, similarly you can try for the rest. N to the power 2 2 power n. Now this 2 is matching with the roots? No. So n square is a quadratic equation. You can write complete form of the quadratic equation, then multiply 2 power n. Finish. Again see, outside don't multiply any constant because already you have constants here. Okay, okay. Now what is the last one? N square plus 1 3 to the power n. It is interesting. 3 to the power n. Yes, this 3 is a root and repeating 2 times, multiple roots. So that now for this 3 to the power n you put n square, and n square plus 1 is also a quadratic, is given in the function. So for that you write this quadratic, so that don't multiply any constant outside. Okay, now we will see the continuation of this video, continuation of this lecture in the next video. Thank you.